Greetings, Saintsman. We have lesson 7.2 for properties of parallelograms. There's a default way to consider parallelograms, and it's really with quadrilaterals. We get this world of quadrilaterals. And your default quadrilateral in your mind, I would probably presume is a square. And I think that that's one of those things that I want to move forward and maybe suggest that there's a better way to consider the world of quadrilaterals. Primarily is that we can divide all the world of parallelograms into, excuse me, all the world of quadrilaterals into, is it a parallelogram or not? A square is a very specific instance of parallelogram. So let's talk about what a parallelogram is in the first place. A parallelogram is a quadrilateral with two sets of opposite sides that are parallel. So the notation that we're going to associate with this is you'll see a parallelogram, actually just drawn, don't circle it. And you'll see, for example, all four vertices, because it's a quadrilateral, listed next to it. Now, one of my pet peeves, mathematically speaking, there is no diamond. Please do not do that. That's like an automatic fail for me. Of the things that I have pet peeves about, spiral notebooks and the use of the word diamond and geometry. Diamonds are a part of geology, not geometry. And we'll go ahead and sketch one here. And I really got to get this software working better. I'm gonna spend some time afterwards to see what the setting is to make this so it can kind of fix my drawings and get some straighter lines here for you guys. Oh gosh, it's really bad. Okay, well, that's what we're gonna live with here. We have this figure here, A, B, C, D. All right, and this is our parallelogram. Now, it has to be listed in clockwise or counterclockwise order, right? A to B to C to D. What I'm not going to see is I'm not going to go from A, and this would have to be B because it's the second in succession, or back the other way if I listed in counterclockwise because I can't go A to C, so C can't be the next adjacent vertex, right? It has to be, we have to skip over it here. Since it's a parallelogram, by definition, what we have here is that the opposite sides, so we have AB and CD are going to be parallel, as well as AD and BC are going to be parallel. Okay? So that's just part of what, again, is defined right here. So AB is parallel to CD. And remember, this is our marking for parallel, right? The two slashes. And BC is parallel to AD. Okay? And that's just what it's defined as. So we're going to do a little proof here, and it has to do with the opposite angles, because there's a bunch of properties that exist, and we can do a series of these proofs, but I want to do one of them, because it's not just, we've talked about this in the world of geometry. This isn't just the practice of trust me, bro. We actually want to use sound deductive reasoning when we are discussing mathematics. So given is our parallelogram ABCD, and we're going to prove that these opposite angles, A and C, are congruent, as well as angles B and D are congruent. All right? So, now, this isn't false advertising. I'm not lying to you. I did tell you guys, yes, in the second semester, there will be no proofs on the final exam. But I'm still going to teach you guys via proof, right? So this is still going to be, right, statements and reasons. Still part of the course, right? Just it's not something you're going to be assessed on. But we understand what I'm doing at least, right? This is why we learn this. So we could actually utilize this in our practice. So I'm going to start with what was given to me, which was the parallelogram itself, A, B, C, D, right? And because of that, we had these other properties that we deduced, right? That with these opposite sides. So AB, which was parallel to CD, and BC, which is parallel to AD. And remember what we put in the reason side, right? Properties, postulates, definitions, and theorems. And this is a definition. This is the definition of a parallelogram. Remember, just up above. This is the definition of parallel. Quadrilateral with two opposite sides that are parallel. So there we go. Our opposite sides and ABCD, ABCD parallel, BC, AD parallel. Now, what we're going to define here is some supplementary angles that we're going to have. For example, angles A and D. Are supplementary. And it's because, remember, we have a parallel AB in CD, and it's cut by that transversal AD, right? So these are consecutive interior angles. Let me show you guys what I'm doing here, okay? So A is supplementary to D. Angle A also is supplementary to angle B. And moreover, angle D is supplementary to angle C. All for the same reasons. These are all consecutive interior angles. So, because of that, remember, we had that whole thing that said if we have two supplementary angles, if we had two angles supplementary to the same angle, they're congruent. It kind of worked through like with the transitive property when we proved it. But that theorem, if you recall from the first semester, was the congruent supplements theorem. So we can actually say that A and C are congruent and B and D are congruent because of the congruent supplements. All right. Pretty straightforward. So there's a number of properties now that we're going to discuss as a result that we have in all these parallelograms, okay? So when we have a parallelogram, these are some of the properties that we can prove, and then these are now characteristics. And when you see a parallelogram, you can make these not assumptions, but conclusions about it. It's that the opposite angles are congruent. It's that the opposite sides are congruent. Is that the diagonal will create two congruent triangles, which you can prove through angle side angle, right? Because we have those congruent supplements, and then we have alternate interior angles, and then we're going to also have, moreover, the reflexive side that is the diagonal. Okay, we'll have the consecutive angles are consecutive interiors, right? So any consecutive angles are consecutive interior, therefore they are supplementary, which we just saw. And if you have one right angle, then you have four. If it's a parallelogram and one of them is right, then all of them are right. Why? Well, because of all the congruence that you're going to have, right? And moreover, because if one's a right angle and its supplement is also going to have to be a right angle, and that's the next consecutive angle, the opposite angle will be congruent, which would also be a right angle. And then, of course, the interior angle sum for 360 of the quadrilateral is going to make the other one have to be 90 as well. 90, 90, 90, 90 for 360. Next. Let's draw. P, Q, R, S. And we have some parallels. And we have some properties here. This guy is going to be 2x degrees for angle P. And R is 54 degrees. QP is going to be 20. And RS is going to be 3y minus 1. And we are going to solve for x and y. Now, remember, let's go back to our properties here. The opposite angles are congruent. So this and this, these are opposite angles. These will be congruent. So that's going to be how we're going to solve for x. So x, we're going to have 2x is equal to 54. Solving for x, divide both sides by 2. So x is going to be equal to 27. That one was straightforward. And then we have the opposite sides. That was the second bullet point here. These are congruent. So 20 and 3y minus 1 are both going to be congruent. All right, so we solve algebraically, add 1 to both sides. So 21 is equal to 3y. Divide by 3 on both sides. So 7 is equal to y. Y is equal to 7. And we're done. All right, let's do another one of these. Now we're going to have no diagram, but we're going to have to be able to use the notation and our own powers of deduction to get the correct answer. So in parallelogram, P, Q, R, S. The measure of angle P is 4 times the measure, oops, not times, of angle Q. And we're going to find the measure of angle P. Okay? Now, what can we deduce here, right? We didn't even give us a picture, but think about this. VQ, right? Because it's asking about angles P and Q. What do we know? Well, we know they're consecutive. And if they're consecutive, going back here, fourth bullet point, consecutive angles are supplementary, right? Because of these two letters happen in succession. So we know that the measure of angle P plus the measure of angle Q has to be 180 degrees, okay? So now let's start to use this information. P is 4 times angle Q. So I'm going to say that 4 times the measure of angle P, I'm sorry, the measure of angle Q is going to take over for the measure of angle P as I substitute. I have 4 times the measure of angle Q. I have measure of angle Q. So 5 times the measure of angle Q. And you guys could substitute it with a variable like x to do the same thing. Okay? And divide both sides by 5, so we can just get the measure of angle Q by itself. All right. Which the measure of angle Q, 180 divided by 5, is going to be, according to your calculator, 36. Okay? So, that's cool, except for that's not what it asks me. It asks me, what is the measure of angle P? All right? So, remember, the measure of angle P plus, in this case, 36, which is the measure of angle Q, is equal to 180. We just subtract 36 from both sides, which will give us 144 for the measure of angle P. All right. We are winding down here because I'm going to consolidate our lesson. I got 2 more things. Remember, it gave us one more thing in terms of defining this. I want you guys to go over is that the diagonals of a parallelogram bisect each other. Okay? So I could do a lot of, and this is where I'm going to start to become more interested in not the sides, but the diagonals of a quadrilateral, because it's only 2 lines I have to account for versus the sides I have to think about 4 sides. So if we go back to the definition, could we deductively prove using the coordinate plane the notion of lines being parallel? And of course we could. We could just go here and calculate the slope for every single side and show that opposite sides match, okay? Which, if this is true, which it is, right? But regarding the diagonals, we only have to do 2 calculations, which are midpoint calculations, okay? So this is what I want to show you guys. Let me just kind of graph this out a little bit. But if I have A, B, C, D, these guys are congruent, okay? Here are my diagonals, okay? This right here, we're going to call point M, which is saying that because it's a parallelogram, AM and MC are congruent, as well simultaneously as DM and MC. These diagonals bisect each other, so each diagonal is bisected at that midpoint where they both, cross here at M. So, that said, let's do the following. We're going to find the coordinates of the intersection of the diagonals of parallelogram ABCD with vertices. A is 1, 0, B is 6, 0, C is 5, 3, and D is 0, 3. Okay, don't need to actually graph anything here. Watch. It's going to be AC right? A, B, C, D. So AC first and third, and then BD second and fourth are going to be my diagonals. So they should have the same midpoint. Okay. Let's show it. So the midpoint of AC first. And now if we find one of them, we've technically found that point of intersection, right? So as soon as we find the midpoint for one of the diagonals. But I'm just going to go a little bit further just to show you the calculation, how well this works out. So AC. So I'm going to take the sum of my x's. It's going to be 1 plus 5 over 2. Okay. And then 0 plus 3 over 2. Okay. So that's going to give me 6 over 2, which is 3, and then just 3 over 2. This is the answer. I technically don't need, because I already know, right? As soon as I have this this midpoint right here calculated, regardless of if I have this other diagonal, I'm done, right? But I want to show you guys the how clean this math is, and it's going to work out. For BD, it's going to be 6 plus 0 over 2 and 0 plus 3 over 2. You can check that out. 6 plus 0 is 0. That's here. 6 plus 0 is 6. Divided by 2 is 3. And of course, 0 plus 3, 3 over 2. Same thing. Okay? There was one example in the previous version of this lesson that I am not going to bother with. So we're going to wrap it up right here. And Saintsman, I wish you guys luck, and come see me during office hours if you have questions.